you look at your 6.4 notes, we're going to talk about rhombi in squares. And a rhombus is a quadrilateral with 4 congruent sides. So that means all the sides are the same. Okay? And a rhombus is a type of parallelogram. Okay? So it shares all the properties of a parallelogram. So that means the opposite sides are parallel. Opposite angles are congruent. The consecutive angles are complementary. Diagonals bisect each other. What is unique about a rhombus is that the diagonals are perpendicular. So when the diagonals intersect, they are creating right angles. So all 4 of these angles are right. They're perpendicular. Also about rhombi is each diagonal of a rhombus bisects a pair of opposite angles. So it's cutting the pair of opposite angles in half. So those are kind of some really important things to remember about rhombi. They're the same thing as a parallelogram. Kind of some unique things is all 4 sides are congruent, the diagonals are perpendicular, and they bisect the angles this time. Diagonals bisect each other because it's parallelogram, but it's also bisecting the angles. Okay, we'll look at example 1. We know AB is 2x plus 3, so I'm going to label that. And we know BC is 5x. And using this information, we're going to find x. Okay, well, in the past when dealing with parallelograms, this would have been a different story because all 4 sides weren't the same. But with rhombi, that's true. This side is the same as this side. All 4 sides are the same. So we can take this information, okay, to help us solve this problem. We can just take 2x plus 3. Set it equal to 5x. They're the same. And get x by itself. Subtract 2x. So it cancels. We're left with 3 is equal to 3x. Divide by 3. X is equal to 1. Okay, so we found x. And b, we need to find, kind of separate the problems, we need to find AD. Well, you might be thinking they didn't give us an equation for AD. But again, the sides are the same. So really, all we have to do is just take 1 and plug it into one of these equations. The equation I'm going to plug it into, I'm going to plug it into 5x. So take 1 and plug it in for x. And 5 times 1 is 5. I just picked that equation because it was the least amount of math. You could have taken 1 and plugged it into 2x plus 3. You still would have gotten 5. You're just making a little more work for yourself. For the next example, we want to find y if the measure of angle 3 is x squared minus 31. Well, we know, because this is a rhombus, okay, we know that this angle is 90 degrees because the diagonals are perpendicular. So we can say y squared minus 31 equals 90. Okay, well, we want to get y by itself, so we're just going to add 31 to both sides. We get y squared is equal to 121. Square root both sides. So we get y is equal to 11. Right? Here's the thing, we took the square root of both sides. You kind of have to remember when you square root something, it's a positive and it's negative. So it's a positive 11, but it's also a negative 11. Because if we were to take negative 11 and we'd still get a positive answer. Always double check. Because negative 11 squared is 121, and 121 minus 31 is 90. Positive 11 squared is 121. 121 minus 31 is 90. So you still get 90 either way. So make sure, I'll write it a little neater too. Should be a plus sign with a minus sign underneath. So it's like plus or minus 11. It should be your final answer. Written a little neater, not much. Okay. Well, for B, we want to find RST. We want to find angle RST. So this angle right here. Okay. Oh, it gave us RST. I'm sorry. It said that RST was 56 degrees. We want to find angle 1 and angle 2 and angle TQS. Taking this information, we want to find all three of those angles. Well, we know it's a rhombus, so we know it's a parallelogram. So we know that RST, which is 56, plus angle 1 and angle 2, it's going to equal 180. Okay. Well, the angle that angle 1 and angle 2 make up is angle QRS. I'm just going to say that that's angle X. So if we add those two angles together, they're going to equal 180. Well, minus 56, X ends up equaling 124 degrees. Oh, that looks like a 9. 124 degrees. Here's the thing. They want angle 1 and angle 2. Well, we talked about this too. The diagonals of a rhombus bisect the angles. So technically this diagonal right here is cutting QRS in half. So angle 1 and angle 2 are the same exact measure. So because the diagonal is cutting in half to give us angle 1 and angle 2, we can just divide that by 2. And 124 divided by 2 gives us 62 degrees. So that would be the measure of angle 1 and the measure of angle 2 equals 62 degrees. Well, to find the measure of TQS, that does not require any work because TQS is the same as RST because they're opposite angles. So TQS is also 56 degrees. There's your final answer. And one last thing to kind of sum things up. We have another kind of parallelogram. It is a square. And a square is a quadrilateral with 4 congruent sides and 4 they're congruent, but there's 4 right angles. It has 4 congruent sides and 4 right angles, okay? And 4 congruent angles. You could also read it as that. So a square is also a type of parallelogram. So by definition, a square is a parallelogram. A square is a rhombus, and a square is a rectangle. Kind of blow your minds there a little bit. A square is a rectangle, but a rectangle is not a square. And a square is a type of rhombus because there's 4 congruent sides. So I'm going to mark our diagram here as 4 right angles. All the sides are the same. The opposite sides are parallel. Diagonals bisect each other. The diagonals form right angles. The diagonals bisect the opposite angle. The list goes on and on. So all the properties that work with a rhombus, all the properties that work with a rectangle, all the properties that work with a parallelogram apply to a square. Squares are kind of easy. You just have to remember pretty much a square is everything. Okay? There you go. You're done with 6.4 notes.